Hello, statistics scholars. This is our first lecture for Chapter 7, Distribution of the Sample Means. The next two slides are the learning objectives for Chapter 7. This is what we're going to go over, and this is what you will need to know for the next proctored exam. Think of these learning objectives as your roadmap through the chapter and your study guide for the next exam. Take a minute, hit the pause button, and read through these. In this lecture video, we will introduce the distribution of sample means and the central limit theorem. The two most fundamental concepts of inferential statistics are 1. Sampling distributions, which are distributions of sample statistics like the mean, not of observations or raw scores, and 2. The central limit theorem, which allows us to find the probability of getting any specific sample and allows us to make inferences from samples about populations. Remember that the location of a raw score in a sample or in a population can be represented with a z-score. Researchers are more interested in studying whole samples rather than single scores. Samples provide us estimates of the population, but samples give us an incomplete picture of the population. There are aspects of the population that may not be included in a sample. The sampling error is the error between a sample statistic and the corresponding population parameter. It is the natural discrepancy found between samples and populations. Error does not mean a mistake was made. Samples vary. No two samples are identical. Samples differ from each other, and sample means differ from each other. Distributions in earlier chapters were distributions of sample scores. Now we will introduce the distribution of sample means, or the sampling distribution. What is a sampling distribution? The sampling distribution of sample means, or sampling distribution for short, refers to the pattern of sample means that will occur as samples are drawn from the population at large. The sampling distribution of sample means presents all possible values for a sample statistic for a given sample size n. It is a theoretical probability distribution of the possible values of some sample statistic, like the mean, that would occur if we were to draw all possible samples of a fixed size from a given population. The sampling distribution allows us to determine whether, given the variability among all possible means, the one sample we've observed is a common outcome or an unusual outcome. For example, let's say I want to conduct a study to determine the number of miles the average person in Southern California drives a car in one day. It is not possible to measure the number of miles driven by every person in this population. So, I randomly choose a sample of 100 people and record how far they have driven. I then randomly sample another 100 drivers in Southern California and record the same information. I do this a total of 5 times. I get the following results. My first sample of 100 drivers, the average miles driven per day were 15.9 miles. My second sample of 100 drivers, the average miles per day were 31.2 miles. My third sample of 100 drivers, the average miles were 27.3 miles. My fourth sample of 100 drivers, the average miles were 22.9 miles. And finally, the fifth sample of 100 drivers, the average miles were 24.8 miles. Each sample has its own mean value, and each value is different. If we could continue this study by selecting and measuring all of the possible samples of n equal to 100 and observe the pattern of sample means. This pattern of sample means represents the sampling distribution for the number of miles the average person in Southern California drives. This sampling distribution is the distribution of sample means because the mean of each sample is our measurement of interest. By taking a sample from a population, we don't know whether the sample mean reflects the population mean. From the sampling distribution, we can calculate the probability of a particular sample mean. Chances are that our observed sample mean comes from the middle of the true sampling distribution. The characteristics of the distribution of sample means are as follows. 1. The sample means should be relatively close to the population mean. 2. The distribution of sample means is approximately normal in shape. Remember that normal means approximately symmetric. 3. In general, the larger the sample size, the closer the sample means should be to the population mean. The characteristics of the distribution of sample means are explained by the central limit theorem. The central limit theorem states that for any population with mean mu and standard deviation sigma, the distribution of sample means for sample size n will have a mean mu and standard deviation of sigma m, and will approach a normal distribution as n approaches infinity.